Welcome, folks. I hope so. You are doing fine. We will wait for some moment more to I guess everyone can join about the stream. But thanks for joining, folks. I hope so. You are having an amazing day. You're doing good around it, and yeah, that's what the main agenda behind. But like, I hope so. You are loving our all the stream that we did. I guess it's kind of sixth or seventh stream. I'm guessing from our side, but I hope so you are loving the whole space around it. And yeah, thanks Toki for joining. Hey Toki. Yeah. So as you all know, I am really damn passionate about WebAssembly or in general WebAssembly open sourcing, and we are bring someone there like for that. And that project I basically met him through a meetup in Hyderabad actually, and really passionate about how they are working on WebAssembly and how WebAssembly can revolutionize everything. Even though we discuss something regarding while I bring Michael Yuan, who is a creator of WebAssembly as a project. So we will talk about also around WebAssembly around in a depth mode, but simultaneously what's for you, how you can learn this technology, how you can contribute to these projects. And yeah, so just give you an intro for our speaker. His name is Radu Matei, and he basically CTO at Fermyon Tech. And he's one of the guy you can basically do a technical stuff brainstorming kind of thing. I can say on that and for 100% surety. But yeah, let me check if there any more comment is there. So yeah, I guess we are good to go. And here is Radu. Yeah, hi Radu, thanks for joining. Yeah.
Thank you for the invite. I'm really excited to chat with everyone in your community. Great to meet you.
For sure, for sure. Thank you. Maybe if I miss any introduction from my side, can you give you a small intro from your side too? Yeah.
Sure. I'm Radu. I'm the co-founder and CTO of Fremyon. I've been around computers my whole life, and so working with computers and getting paid to work with computers was pretty cool. And I'm still continuously amazed that I am getting paid to work with computers. And yeah, so about in November of 2021, we started Fremyon. A few of us came from the same team at Microsoft, and the main thing that sort of put us at the task, like convinced us to start looking in this direction, was for a few years before we were working in the Kubernetes ecosystem. So we were working with distributed systems. I've had been working at this intersection between distributed systems and developer tooling and supply chain security. And we were trying to solve problems that people were using containers for that, right? And if you think about the cloud native ecosystem, a container has for about a decade now become the sort of unit of execution and deployment for computing. And so we went from the virtual machine, which is, you package the entire operating system and a kernel and everything there in a tens of gigabytes file, and then you ship that as your application. And we went from that to containers, which are or about an order of magnitude smaller, but you're still packaging an entire operating system, at least the file system for an operating system. And people were hitting a bunch of problems trying to solve their issues with containers. One of those was startup time. It's really difficult when you have a gigabyte file to have it start really fast. You have to pull it over the wire. It's still operating system and CPU architecture specific. And so once you build a container image for Linux x86, it's going to run on Linux 886, and similarly with Windows and other types of containers. And so we took a step back and tried to think about, well, what if we didn't use containers? What if we looked at something else to solve computing, to solve problems in computing? And so looked really hard at the technology space, and we bumped into something called WebAssembly, which at the time was purely a browser technology. It had just made it to be available in all major browser engines at the time. So this was 2017, 2018 maybe. And we tried to basically look at whether we could use this computing format as the basis for cloud computing and as the basis for running compute everywhere. So if you're not familiar with WebAssembly, WebAssembly is basically a compilation target. Similarly to how you target an operating system in a CPU architecture, this is just a common bytecode format, common binary format. that you target from your programming language, and you generate bytecode in that format, and then that bytecode can run anywhere you can run your WebAssembly runtime. So the initial goal of WebAssembly was this idea that you can take existing programs that had been built for a specific platform, like an operating system, and run them on the web platform. So the quintessential demonstration for this was Quake 2, right? Take Quake 2, which was compiled for Windows, and put it in the browser and run it in WebAssembly there. Since that point, we've come quite a long way with WebAssembly in the browser. You got things like Photoshop and Google Earth and a whole bunch of other programs that have since been compiled to run in the browser because of WebAssembly. So this massive, like millions of lines of codes from code bases in C and C++ and Rust and other languages that can now run in the browser because of this. Our interest was very much the opposite of the browser side of the client side. We were interested in how do we do cloud computing, but with a different type of binary format. And so we spent a few years looking at things like, can you do file system? Can you do file system access, environment variables, configuration, things like how do you open a network connection from WebAssembly and things like that. Along the way, something called the WebAssembly system interface came up called WASI, which defines all of those. Like it's a specification for defining how the WebAssembly sandbox can communicate with the rest of the world when it comes to talking to file systems and environment variables and things like that. And in November of 2021, we looked at all that and thought, yeah, we think we have something here to start a company. So we started Fermyon. And since then, yeah, we started Spin, which is our open source project that we'll dive into a little bit and look at how to contribute to. We've started Fremyon Cloud, which is our hosted cloud platform to run these applications. We have a whole bunch of other open source projects around running.
I guess for the tech industry also for the tech industry also, I guess 2008 is like kind of a very crucial year, because I guess Docker came into play, and simultaneously, I guess I'm guessing I actually, for WebAssembly, to understand WebAssembly, so I go for a C++, like actually I watch 2008 C++ conference. I guess it is in New York. I'm actually not remembering the place actually, just to like understand how it is basically going. But to understand more that part, like I'm seeing from 2008 to 2018, there's so much variation came into WebAssembly. And right now, like Docker's founder is saying, like if we got Wasm plus Wasi, we maybe not able to build Docker at all.
Yeah, I guess it's to your point, over the last about 8 years, there have been so many advancements in cloud computing and distributed systems. And there's a quote that I always like to refer back to, which is, if I've seen further, is because I've been standing on the shoulders of giants, and really because of all the work that had come before every step, right? That this is the only reason why we're able to build on top of this. And so the only reason WebAssembly exists is because of the whole like advancements in compiler infrastructure, and the only reason Kubernetes exists is because containers, and the only reason container exists is because Linux kernel. And you can basically trace all the way back to the 70s to Unix and Bell Labs and to a handful of people. But really, that's where all of this is coming from. To Solomon's quote about if WASI existed, they wouldn't have had to invent Docker. He follows up with Docker's not going away, and it's definitely not going away. Containers and WebAssembly will coexist side by side until the end of distributed systems and distributed computing, which your guess is as good as mine.
But like actually, even though recently, I guess in last 5 years, I'm seeing there's a lot of WebAssembly companies that came up, and they're working on different issues. Like I guess Wasmer came into play for the kind of a Docker plus Wasm kind of thing, like they are doing around that. And I use Wasmer, and it's super fast, like literally super fast. And comparatively, what the performance based, like generally people say, like there's only two factor that there's a technological change. One is the performance part, if it is performing good, or it is totally new thing, like a total infrastructure is totally new. So what you put in WebAssembly from according to your space, like, is it the performance based thing, or it's a totally new infrastructure or new architecture to the whole tech, maybe tech industry for that? So
Yeah.
like, what's your take on that? Yeah.
Yeah. So I can refer back to what our thinking was when back before we started Fermyon, right? The reason we looked at WebAssembly back then was you have something that is supposed to run in a sandbox, right? The browser is a sandbox that you kind of trust implicitly every single day, right? You have your banking tab and you have your like Reddit or whatever, TikTok, whatever you have might happen to run in a browser, and you're pretty sure that one tab cannot access the data from another tab. And so the security sandbox is something that you have come to trust implicitly from browsers. And when WebAssembly was designed, one of its primary goals was to keep that sort of isolation sandbox that the browser gives you. And so isolation and security was very, very high on the list of things you wanted out of this new computing unit, execution unit. And so security and sandbox isolation really, really high on that list. The second one is platform portability and runtime portability. If you think about it, when you design a website, you're no longer thinking about, oh, this website is going to be accessed via Windows with Internet Explorer 11, or a Chrome on a Linux, or Chromium on Linux, or Mac on Safari, right? And so you're kind of required that whenever you access a page, that can be accessed across across operating systems, across CPU architectures of your machine. And so that sort of portability was pretty important for us. Back in our work at Microsoft, we worked with both internal Azure engineering teams and customers who had hybrid infrastructure, comprised of both Windows containers, Linux containers. They also had ARM CPUs and Linux, x86 CPUs. And so defining one type of computing unit that can run across all of those was pretty important for us. And so WebAssembly takes that as well, right? Implicitly, WebAssembly has to be able to solve for that. The third one, the third reason why we looked at WebAssembly was when you open a web page, similarly to what I was saying earlier, you're no longer waiting for like 10 seconds for the page to load. You're expecting the page to instantly start up. And so two requirements come out of that. The first one is it really has to be a compact format. You really need to just package your application and nothing else in that module, in that binary. And the second one is once you fetch it from some network, it really has to start really fast. And so put those together, those are the reasons why you chose WebAssembly. It's isolation sandbox. You want to be able to run multiple components on the same machine side by side and be certain that none of it can access the data of anything else. Good. Similarly, none of it can access data from the host or other modules. It has to be entirely portable across existing operating systems, existing CPU architectures, and ideally future CPU architectures. So risk is a conversation there to be had. And then it has to be really compact and really, really fast to start. And so the combination of those is why we looked at WebAssembly and thought, yeah, this is something that can significantly improve the status quo of computing and can improve how people think about building and then distributing applications. And we'll get a little bit into that later with one of the things that we really focused on top of the benefits from WebAssembly, what we looked at and what we wanted to focus on when we built Spin and then Fermyon Cloud as well.
Got it. Maybe this is maybe my first question, but it's kind of like we have a lot of interesting talks we happened just right now. But this is a take for every stream. What I asked, like, what is your definition of open source from your term? For everyone have a different perspective, because everyone is not a developer, and open source as a community like brings everyone, like even though it's designer, technical documentation contributor, anyone. So what's your take around what is open source to you?
So to your point, I think it's easy enough to go to the opensource.org website and go through the definition of what what the official definition is for WebAssembly for open source. And I think there's a contrast there with FOSS, with free and open source. I think for me, having explored both those ecosystems, I think primarily the most important thing when I think about open source is a community of like-minded people who want to contribute to a single goal of making a project successful and basically reaping the benefits out of that project being successful, right? And whether that's developing a feature or contributing a bug fix or making a feature request or writing documentation or creating a logo or writing examples or writing or making YouTube streams about the project, like everything is encompassed in that, in the goal of making the project successful. And of course, you can get into the definitions and you get into the details of licenses and Apache, MIT, and GNU, and a bunch of other licenses. But to me, the open source, what lies at the heart of open source is a group of like-minded people trying to make a project successful.
Nice. Maybe we can go with the thing about, can you share your screen and talk, or like just share about the GitHub of Fermyon and like explore about that part if possible.
Sure. Let me try and share.
Yeah. By the way, by the folks, I actually dropped down the links of Fermyon GitHub repository. You can check it out. And also, I share the Discord link. I guess it is showing it here. So if you want, I will say you love the project. I always, because I use that. So go to the Discord server. If you feel any queries, again, like team is there to help you all. But yeah, I guess this is stage one.
Okay. Let me know if you can see my screen.
Yeah, I can see your screen. Yeah.
So all of our open source happens on github.com/Fremyon. And the primary project that we're gonna have a look at is Spin. Spin is basically our open source developer tool for building and running serverless applications powered by WebAssembly. And we've talked about WebAssembly a little bit, and at some point I'm going to dive a bit into why we looked at serverless as the primary workload to focus on for now. But the TLDR for that is we looked at all the characteristics of WebAssembly, in particular the really fast startup time and compact binary format size. And because of that, Spin makes it really easy to write a program and to compile it to WebAssembly and then have it be executed instantly and basically start it from scratch. So you write your application, it might have like tens or hundreds of components, of WebAssembly components. You only execute code when you get a request for it. So before we get a request, nothing's running. When you get a request, instantiate the WebAssembly component, execute it, run your handler function, and then shut everything down. And so that's the gist of what makes Spin really fast. It's using WebAssembly behind the scenes, and we've built a really simple developer experience on top of all of that. And so if you go to fermyon.com/spin, you'll find the main project repository for Fermyon Spin. As I mentioned, Spin is entirely open source. It's Apache 2 licensed, which means you can fork it, make it your own, change anything you might like. We would love it if you contributed back to the project, and we'll have a quick look at all of it. But in a nutshell, Spin is actually a few projects in a single repo. So primarily, you'll interact with the developer tool, which is the Spin CLI. If you go to Spin 1.5, the latest release of Spin, you'll find the release binaries, and you'll get the Spin CLI. But inside the Spin project, you'll find the entire engine for executing WebAssembly at scale. So if you look at the repo in the crates directory, I mentioned briefly a few minutes ago that besides Spin, our other main project is called Fremyon Cloud, which is our hosted platform for running WebAssembly. We take the core of Spin and reassemble it in a way that makes it really easy for us to run WebAssembly at scale. But it's primarily the same core from this project, and so it has to be something that we can assemble really easily into Fremyon Cloud as well. And all of that is also open source, and it's in the crates directory here. So if you go to the source directory, you'll find the CLI. This is the Spin CLI source code file that gets executed when you run the Spin command. And then here you'll find all of the commands that you can interact with when doing Spin. So this is the Spin repo. And then if you go to developer.fermyon.com, let me zoom in a little bit. You'll find the documentation for how to get started with Spin and how to get started with using Spin first and foremost. So you'll find a quick start of how do you install Spin, how you configure it, and then get started with the language of your choice, whether that's Rust or TypeScript or Python or TinyGo. There's support for a few other languages, but these are the ones we have initial documentation for. And then you'll find a bunch of examples of applications you can build with Spin, and then a step-by-step guide on how to actually use all the parts of Spin. So if you go through the documentation, you'll find examples on how to get started with your first app, how to build your application, how to run your application locally, how to push it to a container registry, and then you'll have the language guides for all of the languages that we have support for, and then you'll find examples on how to use the built-in key value store with Spin, or how to write applications that use, for example, a Redis database or a relational database like SQLite, or how to use the latest feature that we released in Fremyon Cloud called Serverless AI. So if you're interested in that, I'm happy to dive into any of those. Last thing I want to show you before going back to the repo is the Spin Up Hub, which is the place where everyone in the community publishes templates, examples, samples, tutorials, plugins that they built with Spin. So if you're interested in writing an example or writing an application or writing a template, please submit it to the Spin Up Hub. That's how everyone from the community can find this, can find your sample, your tutorial, your example, and use that as a starting point for their application. So there are a lot of examples submitted by people from the community around basically anything from writing a WebAssembly component to using Spin with static website generator to building short links and QR codes to using Spin with Kubernetes and Docker and Dapper and a whole bunch of other projects. So I really urge you to have a look at the Spin Up Hub.
Yeah, it's a great way to folks for contribute to like the project in general, because you can understand the stack, how actually Spin is working. Like in general, it's always happened like creating a tutorial or writing a unit test is the best way to understand the project, because it gives you more insights about the workflow of the project. And yeah, I know many developers hate writing testing suits, but it's a great way to basically you can contribute to a project. Yeah, you can carry on, Radu. Yeah.
Yep. And then lastly, if you go to fermyon.com and if you scroll all the way down, you'll find the link to join our Discord. And if you're interested in chatting with other people from the community, there are about 1,000 or more people in our Discord server. If you're interested in chatting about Spin, WebAssembly, computers in general, please join. We would love to have a chat with all of you all there. If you go back to the Spin repo, I mentioned in the crates directory, there's pretty much all of the functionality of how Spin works behind the scenes. And then if you look at the issues, we have a whole bunch of feature requests and planned work for the future that we've decided to keep track of, and a lot of opportunities for people to contribute to. There are a few issues labeled as good first issue, and really this is the way I would suggest people start contributing to Spin. So these are issues that were opened by people from the community or people from Fermyon, and basically they are specific enough, and the ask and the feature request is specific enough that it should be easy for someone to grab a good first issue and start implementing it, regardless of their level of experience with the programming language here. One thing that I think it's worth mentioning is Spin is primarily written in Rust. If you look at the report for the repository, it's 86.5% written in Rust. Most of the core functionality of Spin, so both the CLI and then the internal engine and how it loads and executes applications, all of that is written in Rust. Even if you're not a Rust developer, though, I would still suggest, one, if you're interested in contributing and learning Rust, the Good First Issues might be a good place for you to start that journey. I really suggest you do that. If you've never written a Rust program before, I think the simplest way would be to you go to developer.fermyon.com. In the Spin documentation, language guides. There's a Rust language guide for building Spin components in Rust. And this has examples and documentation for pretty much anything that you would do with Spin in Rust. So whether you're building a web server, an HTTP component, whether you're building a Redis component, and things like sending requests and storing data in SQLite and key value storage. So if you're interested in like getting started with your Rust journey, writing Spin applications in Rust might be a good start for you. And there are a bunch of people in our Discord server who would love to help you get started and block you if you have any questions on Rust.
I already dropped all the links in the comments. So if you feel, or after the stream also, I will add all these links in the description box so you can check it out. And you can, otherwise, the best way you can go also, if from comments and description is not able to do that, you can directly go to the website of Fermyon and you can directly join Discord from there also. Yeah.
Yep. So we really at Fermyon, we really love Rust. It's one of our favorite programming languages, and we built a whole bunch of things in Rust, both open source and for Fermyon Cloud. But that's not the only language that we use at Fermyon, and that's not the only language that you could get started with contributing to our open source projects. Let me list the public repos. So besides Rust, we have a whole bunch of other projects that might be written in Rust, might not. And the first one I'd look to are the Spin SDKs. So Spin has Spin runs WebAssembly, and to execute a WebAssembly module, you have to have something compiled to WebAssembly. And so that source language can be anything that compiles to WebAssembly. We have a tiny layer on top of programming languages that compile to WebAssembly that make it really easy for people to write idiomatic code in that language. And so if you're writing a Rust application with Spin, there's an SDK for it. And in the primary Spin repo, we have the SDKs for Go and Rust. If you're familiar with the Go programming language, Spin has an SDK for it. It uses TinyGo for now to compile things to WebAssembly. We're also tracking the developments in upstream Go to work with WASI, with WASI Preview 1. And so if you're interested in the Go programming language and WebAssembly, I would love to have more people contribute to our Go SDK and to make it even more idiomatic and to have it support even more of the Go ecosystem. So I strongly recommend you if you search for
there is one question, Radu, how have you built the WebAssembly toolkit properly totally from scratch for the Spin, or it's like you use the specific any tool like mscriptum tool or like something else like that which basically supports the WebAssembly? So like how you basically created the WebAssembly ecosystem over there, like someone is
so there are two parts to that question. The first part is, so if you think about the WebAssembly ecosystem, you usually have a guest, something that you compile to WebAssembly, and then you have a host, which is the component that executes WebAssembly. And so Spin is primarily the thing that runs WebAssembly, built on top of the WebAssembly runtime. And then you use the Spin SDKs and your language tooling to compile your code to WebAssembly and then have it run by your WebAssembly runtime. So I'll start with the host first, because this is This is an interesting one. Spin is built on top of the Wasmtime project, which is a bytecode alliance project. It's basically the WebAssembly runtime that's designed to be really fast and really secure. And Spin is built on top of the Wasmtime runtime. We use it because of its both performance and then really good security stance. It does things like fuzzy testing, and often it does security audits and a whole bunch of other things there. We also contribute a lot to Wasmtime, and so essentially Spin is built on top of the Wasmtime and on top of the component model and on top of WASI, and that's how the runtime part of Spin is built. The guests. Go ahead.
Yeah, there is a, I will not say a lame question, but yeah, every question is obviously good. Someone is asking what is WASI, like, I guess there's someone who didn't know what WASI actually. Can you elaborate a little bit about WASI?
Yeah. So take a step back. We talked about WebAssembly as this sandbox environment.
Yeah.
It lets you execute code and be certain that the code that you're executing does not have access to anything outside of its sandbox. So it literally has access to its linear memory and nothing else. That's great for the sandbox security that we talked about. It's great for running untrusted code. But most of the time, you need your application to have access to things like files and environment variables and be able to make network calls and so things that you would normally do as part of your application. And so WASI stands for the WebAssembly System Interface. WebAssembly WASI. So WebAssembly stands for WASI stands for the WebAssembly System Interface, and it's the specification that defines how WebAssembly components can interact with their host environment in a standardized way. It initially started as a basically tracking how Unix systems treat system access. So if you think about the POSIX layer, it started as resembling the POSIX layer. It evolved since then in a way to basically define those APIs and define how a guest component can talk to a host. And if you look through the repo, you'll find specifically the APIs and the function signatures for how a guest is expected to communicate with the host, to open files, to make network connections, to read environment variables, and things like that. So it's that's what WASI is, and essentially Spin is built on top of Wasmtime, the component model, and then WASI.
Got it. Yeah, I guess the question is clear. Yeah, he got it. Yeah.
Cool. So going back for a second, the distinction between the guest and the host. We looked at the host built on top of Wasmtime, built on top of WASI. The guest, on the other hand, is the program that you as a user target. And specifically, you need a tool chain that compiles your application to WebAssembly. Spin is not opinionated about that at all. If you have a tool, a language, a programming language, and a tool chain that compiles code to WebAssembly, Spin will run it for you. That being said, we do try to make it really easy using the language SDKs. And so for Rust, we use the official Rust toolchain, Cargo. Cargo at Rust and the Rust ecosystem, they have really good support for WebAssembly, which is why we just use the Cargo ecosystem with a really, really small SDK on top of to make it idiomatic. For Go, we use the TinyGo toolchain for Spin. It's a compiler built for the Go programming language that's really, really small and generates compact WebAssembly programs. Over the last few months, the Go team at Google has been making a lot of progress on compiling Go to WebAssembly using the upstream using the official compiler. And so over the next few months, I think we are going to update the Go tooling and the Go SDK for Spin to use the upstream in the official programming compiler from Google. And then we have a whole bunch of other language SDKs. One that I'll look a little bit into is the JavaScript SDK, which is essentially a program that takes your JavaScript and packages it together with a small JavaScript runtime and compiles the whole package to a WebAssembly module. And so it has the sort of idiomatic JavaScript API surface that lets you write applications with this, and then also the tooling necessary for you to package that to a WebAssembly module. So this behind the scenes is using Quick.js and the Javi project from Shopify, and it builds on top of that to take your JavaScript code and then compile it to WebAssembly module. We're working really hard to update this to use the SpiderMonkey project from Mozilla, and there are a few other SDKs. So if you search for SDK here, you'll find the Python SDK, which is a similar project to the JavaScript SDK, this time for Python. It takes CPython, the CPython project, and your Python source code, and similarly initializes the Python interpreter with your source code and packages everything as WebAssembly module. As I mentioned, if you're interested in contributing and if you have experience in like JavaScript or Python, we also have SDKs for .NET or other languages. If you're interested and if you have experience with any of those languages, this would be a really good opportunity for you to contribute to projects that are in the WebAssembly ecosystem, but are not necessarily just Rust. If you look at both the JavaScript and the Python SDKs, they do have a significant Rust layer, just because that's how we found it easiest to integrate with the rest of the WebAssembly ecosystem. But the language that you're writing when creating components is Python or JavaScript or C# or whatever else that you might run. So if you're
there is one more question, like kind of like which language do you prefer to go with maybe Spin, like in terms of which is better in comparison to compile the whole stuff, like kind of that.
One thing that was pretty surprising the first time I got into WebAssembly, at least, was my assumption was, well, once you compile something to WebAssembly, it's going to perform the same regardless of the source language, right? Because it's compiled to this common bytecode format and nothing else matters, right? In reality, it's not quite like that. Specifically, if you take, for example, C and C#, right? Today, the way C# runs inside WebAssembly is by taking the C#, the .NET interpreter, and compiling that to WebAssembly, which means you have to actually compile or at least parts of the .NET interpreter, the parts of the .NET runtime to WebAssembly, and that is going to execute your DLL, your dynamic link library that you compile your C# to. And then you take the entire package, the .NET runtime and your source code, and package that together as a WebAssembly module. And so that takes time to initialize. The performance characteristics of that is different compared to that of raw C, for example. And so there are differences in terms of performance between C and Rust and JavaScript and Python and C#. So if performance is really, really important to you, to your scenario, Rust, I would suggest as the most, if you're super comfortable with C and C++, that's always going to have the best performance. And that's true whether we're talking about native code, whether we're talking about WebAssembly. So that will always have the best performance. Rust is really, really close. And so between the language ergonomics, the tooling, and the ecosystem that's tailored for WebAssembly, Rust is definitely my favorite, just because it's one of my favorite languages, and it has really good support for the WebAssembly ecosystem. Funnily enough, Rust and WebAssembly started around the same team at Mozilla initially. So they were developed hand in hand by a common group of people who were really excited by both of them. And so Rust happens to have one of the best supports for WebAssembly out there.
Okay, the same question with a more twist. There's one someone is asking, like, if we have to think around more on a machine learning side, like we have to train the models around that and we have to deploy it in the production side, then what do you prefer over that point?
For machine learning, it's the primary question is, do you know the runtime environment for which you have to build? If you're supposed to build an inferencing engine that runs on top of something like PyTorch or NumPy or something like that, the simplest answer here is go for Python, right? Python is by far the most robust and the most popular language in the data science and machine learning communities, and it's something that it's impossible to go wrong by learning Python and by learning something like PyTorch or TensorFlow or JAX or whatever else.
Yeah,
right? It's really impossible to go wrong here. If you are interested in deploying your machine learning projects and your inferencing engines on something that's not like a VM that runs Linux and it has a GPU that runs all the time, because that might be a requirement. But if you don't have that requirement, and if you're interested in writing something that maybe runs infrequently, or maybe you don't want to pay for a GPU all the time, and obviously I'm involved in this, so I strongly recommend looking at the Spin project, particularly for language models. So if you look at the developer documentation in the serverless AI project. So as I mentioned, last month at Fermyon, we released Fermyon Serverless AI, which is a set of services that lets you create inferencing operations and lets you do language embeddings and other things that I will get into a little bit later using Spin and Fermyon Cloud. And so specifically, it lets you, without paying for a GPU a whole month, it lets you build a true serverless application that you can deploy onto your own infrastructure or onto Fermyon Cloud, that lets you run Llama 2 chat and Code Llama Instruct, the code generation model from Meta, in a way that it's truly serverless, right? And so in a way that lets you avoid having to either pay for a GPU an entire month or pay the cold start of like waiting for 2 minutes for your machine to start before it can perform an inferencing operation. And so if you're interested in this, we have examples in Rust and TypeScript and Python as well. And I suggest you have a look at basically how to infuse AI capabilities into your own applications without having to either learn machine learning from scratch, or having to like just learn Python, or having to like work on generating the infrastructure and setting up the infrastructure and getting a GPU and all of that. This is a really simple way for you to start prototyping with language models and large language models and embeddings and other AI capabilities into your own serverless applications. So if you're interested in that, again, developer.fermyon.com, you should find all of the examples there. And then similarly, on Discord, you'll find a lot of people who are interested in chatting about all of this.
I guess Talker is asking, can you share some best resources to get started with WebAssembly?
Yeah, some best. Oh, that's an interesting one. I haven't thought about that in a while. Okay, let's WebAssembly.org. Okay, WebAssembly.org is like, you cannot go wrong with this. It's the official website for the specification and for the WebAssembly community. And here you'll find most of the resources to get started, specifically both for outside and primarily for client side, but also outside the browser. Fermyon assembly. If you're interested in finding and in learning about which languages have support for WebAssembly, on Fermyon.com, we do have a page that basically tracks support for most of the languages and has examples on how all of these work. So we have an article, a documentation article describing support for all of those. So we track the support for the top 20 programming languages. And in this report, you basically have both a quick glance of, oh, is this supported in my favorite language? And then you have also a usage example and a template on how to get started with all of this. So if you go to Fermyon.com/WASM-languages, that's where we should find a lot of information about what is WebAssembly, what is WASI, what is the component model, what is the support today for Swift in WebAssembly, for example, right? And if you click on this, you'll find an example and a tutorial on how to get started with all of this. So
yeah, I guess maybe for me, it's always Twitter. WebAssembly Weekly is a nice Twitter handle you can follow. Like they actually tweets around WebAssembly around it. So you can obviously check that also. Yeah.
Yep.
Cool. I guess there is nothing question from the chat. Let me check.
Cool.
Yeah, like people is saying we love the session because it's a new thing for us. As in terms of WebAssembly point of view, but maybe this kind of my question, why you think maybe serverless can be grow, even though someone have a talks around, like in industry also some talks around serverless kind of a dead, maybe it's not good for some good production level products kind of thing. So why, like, you think of maybe WebAssembly can maybe can boost that serverless part, basically that kind of thing? Like, what's your take on that? Like, many people have a same. Even I watched some of the reviews of some of the YouTubers who basically talks about the technical architecture around it, and maybe they are saying maybe serverless kind of a dead. So what's your take on it, basically?
Yeah, I think I used to work on briefly on Azure Functions a few years ago, and one of the things that attracted me to that platform the most, and since then I've become quite familiar with Lambda and other Google Cloud Functions and other serverless offerings. And one of the things that always attracted me to that was the programming model. The programming model of, instead of starting your application with setting up a web server and handling TLS and like doing all of that manually every time you start a service, instead of that, you're 100% focused on your business logic. And that is, you get a request in, you handle it, like read the body, do something, and then get a response out. And that programming model, that function based programming model, was something that I was really, really excited about, and is one of the things that we really wanted to make sure makes its way into how Spin works. If you start a new component in Spin, whether that's Rust or JavaScript or C#, whatever that might be, what you are met with is a function, a handler function that takes a request in and returns a response. That is as idiomatic as it can get for your source programming language. So to me, serverless is primarily the programming model. The second thing that, talking to a lot of people who've used serverless before, they talked about, well, we love the programming model, but the developer experience was not great. Not bashing on any particular product or company, but the developer experience of getting your serverless application deployed from scratch could take, at least last time we tried it, anywhere from 20 to 45 minutes, and that was not particularly great, right? You want to like really have a really, really good developer experience. And so those two in particular, the programming model and the developer experience, we wanted to really make sure that A, is something we just get better at, and two, are at the heart of how the Spin project operates and how the Spin project works. WebAssembly specific now, one of the things that I talked about earlier was around startup time and the compact binary size. And if you go past the developer experience of serverless, the first thing that people start talking about is, well, I deployed my serverless endpoint, but the cold starts are killing me. That means specifically how, at least in how popular serverless products work, that means that there's a virtual machine somewhere that has to start in order for your serverless endpoint to be served. And so that can take anywhere between 200, 300 milliseconds to 700, 800 milliseconds, depending on the language and the ecosystem. And so with WebAssembly, what we've observed is between the compact binary size that lets you compile your entire program into like 2 megabytes, and the really, really fast startup time of WebAssembly, which that is can be lower, like below 1 millisecond. Like when you put those two together, you can get cold startup times that are really, really fast. And so if you're able to improve the cold starts for programs by an order of magnitude, that's something that we are really, really keen on solving. And then last, even if you're like the definition of serverless a lot of the time includes things like you don't have to think about the server anymore. Well, that's just not true these days, specifically because if it's a container-based serverless environment, the top line of your Docker file is from Ubuntu 18.04 x86, right? And so you're fundamentally thinking about the platform architecture and operating system of the target server that your code is going to run on, which means with things like Graviton, like the ARM instances in the cloud today, you have to rebuild and maybe like change something about your application, or at least rebuild it and repush it because the server changed, right? And so serverless really, really is a placeholder for anyone who thinks about WebAssembly thinks about some parts of those. And what we wanted to do is just take a holistic approach to all of this and think about the programming model, think about the developer experience, think about the performance, and really think about the platform independence. Finally, there's one thing that I do want to mention, which is when we looked at the types of workloads that were really suited for WebAssembly, when we started at least, and some of that is true today as well, but less so. The sort of fast-firing, short-lived function aspect made a lot of sense, in particular because there were things in the WebAssembly ecosystem that were just not mature just yet. One example of that is garbage collection, which means the way garbage collection works is if you have a long-running process, every once in a while, a process comes in and collects unused memory. Because that wasn't implemented in WebAssembly, you couldn't, like, your memory could grow, but it could never shrink. Which means if you want to run a program for like 80 hours or something, that memory could like grow until it runs out of memory, which is not great. And so going back for a second at the reason why we chose serverless is it really is WebAssembly was really, really well suited at the time for the type of short-lived, fast-firing function aspect that we looked at the time. And so that's the one of the reasons, like the combination of those is why we chose to start with serverless. That being said, the way Spin works, there's nothing there that would prevent you from being able to run Spin applications for days or weeks. And even so, some aspects of WebAssembly, like being able to move running instances around, make it probably even better suited for those long-running processes that you can move around without having to stop it. And so, as the WebAssembly ecosystem matures and as the tooling progresses, WebAssembly and Spin in particular are absolutely not limited to just serverless, and it's just serverless was just the easiest and most appropriate workload for us to get started with. And so, as other types of workloads emerge and as other type of things start getting popular in WebAssembly, we are pretty much excited and willing to support other workload shapes out there.
Yep. And that's why like I like about like while I'm going through the Rust documentation actually like to learn basically, I got that the garbage collection part that Rust is doing is totally amazing. Like I think of why any other language can't think of to how to manage the whole garbage collection kind of thing, or to basically save the memory on that point of like, yeah, I guess there's a concept called if there's a part of in the scope, so you get a kind of a responsibility for that particular stack basically. And when it got out, so memory totally like you can clean up the memory on that point only. So
Yep.
that's
The
that's
borrow
actually I
checker.
like.
Yep.
Yeah,
Yeah, that's the
so
borrow
that's I
checker.
like about it. Yeah.
It's
so
really, really good. Yeah.
so that's basically makes me more exciting for the Rust and WebAssembly in a simultaneous manner, because they are supporting each other like on that part. That's why maybe maximum people right now, if they're working on a product with the WebAssembly thing, they are trying to more focus on the Rust only, because it's like compatibility factor is really good between both, I
Yeah.
guess.
I think Rust and WebAssembly, in a sense, is a self-fulfilling prophecy. In a sense, particularly
Yes.
because it has the best tooling for WebAssembly, and because it
Yeah.
has the best tooling, everyone writes tooling in Rust for WebAssembly because it has the best
Yeah.
tooling, and so it's a sort of circle that.
Circle. Yeah.
Yep. That being said,
But
I know the Microsoft team, the C# team
yeah.
at Microsoft, and the .NET team, they've
Yeah.
made a lot of progress on .NET, and ahead of time
Yeah.
compiling .NET code directly to WebAssembly. The Go team has done amazing work to support WASI in the latest release of Go, and they're still working on that.
Yeah.
The Kotlin team has like amazing support for WebAssembly and WASI as well, and so there are a lot of like Python similarly, right? Really good support there. And so there are a lot of language ecosystems that are starting to, at least if not already, have really good support for WebAssembly. And so really, if you take a step back, there are two factors that are happening at the same time, and that is, as far as I can tell, only accelerating. On one hand, you have programming languages and language ecosystems that are adding support for WebAssembly, as I mentioned, Rust and JavaScript and C# and Python and Kotlin and Swift and more languages as time goes on. And on the other hand, you have a whole bunch of specific environments where people are looking at running WebAssembly. We looked at cloud computing and serverless. Others are looking at plugins and IoT and machine learning. And people are running like BBC. The BBC team is running WebAssembly on their boxes, like on their physical boxes,
Yeah.
and the Amazon Prime team as well. Similarly, Disney, right? So
Yeah.
there are a whole bunch of specific scenarios where people are looking at running WebAssembly directly in ecosystem. And so when you put those together, you can start like inferring the impact that WebAssembly already has today on computing, but the impact that it will have once everything falls into place. And I'm really excited about that future.
Yeah, like even though I think so, think of like I guess Microsoft came up the thing with I called Blazor, I guess, for the WebAssembly thing, like they are trying to work on that thing. So I'm really excited like what Microsoft came into play around WebAssembly stuff. But
Oh yeah.
yeah, I guess I'm even it's from my side, like kind of 6 p.m. IST, so I didn't take much of your time, obviously, Radu. But really appreciated, Radu. Thanks for sharing all about the WebAssembly, Fermyon, and folks, those who are watching us. I updated the things in the description box, so you can find all the links. Join the Discord server, use the project, and if you feel, do contribute to it. I guess many beginner-friendly issues are already open, so you can contribute to it. Maybe in this week I will start off contributing to Fermyon because I use always in my small projects. So I will definitely contribute to that for sure. And
Please. Yeah, and then I'll leave you with please have a look at the Spin project, have a look at
yep.
contributing the Spin, and maybe deploy your applications to Fremyon Cloud. That would be excellent, and we would really much appreciate that. We have a pretty generous free tier, so please have a look at that.
Yeah, thanks, Vinayak. I hope you love the session. So yeah, I didn't take much time, but at the end, we are directly on 26th, I guess. We are doing a stream with GitHub education team on talking about the how you can contribute in open source through advocacy, like developer advocacy. So this is the next thing that we are going to do it. And I know it's more on a non-technical aspect to it, but I guess through open source point of view, it's a lot of thing like what came into advocacy actually. But yeah, I will see you there. But thanks again, really appreciate it, Radu. Thanks for joining and sharing your insights with us. And I hope so my community will love something around it. And yeah, thank you for that. Yeah.
It was my pleasure. Great to see you again. Bye.
Yes, see you, Radu, and I will ping you in the backstage for now. Until then, folks, all the links are in the description box. Again, go follow Radu on Twitter. He's kind of like, because through many aspects to it, I learned a lot of thing. Okay, I guess thanks, Takir. I guess it's an awesome session. So yeah, thank you, Takir, for that. But do follow Radu and follow me also if you want. But I didn't force you or to do that for the same. But yeah, see you soon. And I hope so everything is go fine from all the end. And let's wait for the next stream, I guess. Till then, see you, tata, bye bye, and have fun. See ya, bye bye.